Testing in production. What is the first reaction when you hear the term testing in production? Well, here are a couple of images representing the top results from Google when you search the term. Hi, I'm Kranthi Challa, Senior Site Reliability Engineer with the Website Tooling and Delivery team at Netflix. Today, I'd like to talk about how we do testing in production in our team and share a few insights. We will start with laying down the core concept, touch base on a few different ways we do testing in production, and dive deeper into the Canary release process. We will wrap the talk up with a few key takeaways. With that, let's dig in a little more. What does testing in production mean? It definitely does not mean deploying untested code to production. Neither is it meant to replace staging environment. It is a practice of continuing testing, intentional testing into production environment, and continuously monitoring the system and quality of experience post-production. A key factor in enabling us to successfully test in production is how strong is the service's observability or monitoring story is. Because without good observability in the production system, it is impossible to evaluate how viable a new build or version is. Why do this? What are the benefits? There are a few. Intentional testing in production prior to a release enables much faster feedback loop, ultimately minimizing the risk of user impact, which means basically you're making the service more reliable. This also allows us to analyze live user experience, and not to mention the ease this practice provides for performance testing, and also the diverse set of platforms it inherently provides. This enables us for data-driven decision making, as opposed to releasing a build into production and just hoping it works. How is this implemented? It's done in many different ways across the industry. The three listed here, feature flags, A/B testing, and canaries, are some of the more popular ones. Feature flags. Feature flags are primarily leveraged to control the feature flow. Especially the aim is to decouple feature releases from code releases. This also gives an advantage if you have to roll back a feature independently without affecting anything else or any other code that went along with the code to enable this. A/B testing. A/B testing is widely used to test the viability of a feature. It's one of the heavily leveraged experimentation here at Netflix. This primarily targets the business outcomes or business metrics. Canaries. Canaries, we will be diving a bit deeper into the canaries in just a bit. But at the surface, the idea is exactly what the name canary means. Very much like in the olden days, how a canary bird is used to detect gases in coal mines, we sample a new build with a small fraction of users before rolling it out more widely. This process targets more on the system, performance, and quality of experience metrics. Note that these three testing strategies primarily serve very different purposes of testing in production, but they can be used variably and interchangeably depending on how we choose to implement them, and also depending upon what is the problem that we're trying to solve with these. Let's take a look at these strategies a little deeper. Feature flags or feature toggles. As we just discussed, feature flags are primarily leveraged to control the life cycle of a feature. The main aim here is to decouple decision points from decision logic. So by adding a flag or conditional logic to a feature, we are able to deploy the code anytime, but control the feature availability to users via a toggle. As a side effect, the toggling also gives us an ability to roll back independently without impacting anything or any other feature in the service. There are many kinds of toggles. This one that we just discussed about the release and the rollback is more a release toggle. Depending upon how the logic is structured and enabled, it is possible to toggle these flags for all users or a subset of users. Those categorized under permission toggles. Also, because of the flexibility this flag provides, it is possible for us to test a feature in production for a certain period of time for experimentation, which is exactly what a A/B testing would be doing. So as you can see, there are different types of toggles and different types of implementations. Depending upon the problem that we are trying to solve, we are able to use them variably. Though as much flexibility that feature flags are bringing to the table, I do refer them as double-edged swords because of the complexity they do bring with them. Particularly, it's very easy for the number of flags to go out of control very easily and very quickly. Thus, it also brings a need to have a life cycle management. So, you know, when how long is this toggle needed and how stable or dynamic is this flag going to be? There's a need to come up with a system to manage the life cycle of these feature flags. So the idea is to be cautiously implementing these feature flags and making sure, we cross the T's and dots the I's with respect to the lifecycle management. Let's look at the A/B testing next. As the name suggests, a subset of users, sampled randomly or strategically based on a device IP or a profile, gets to experience a variant version, which is let's call it version B, while the rest of the user base has the same the existing production version, which is version A. The outcomes of version A and version B are basically compared, and I mean the business outcomes are compared to confirm the hypothesis that this change proposed in the version B, and that this change is actually taking us, the product in the right direction or the business goal. What does this do? What does this enable? It enables better decisions, as in data-driven decisions, as opposed to implementing features, and hoping that the customers or the users would love it or like it. Canary. Canary release is a technique to reduce the risk of introducing new software version in production. This is done by slowly rolling out the change to a small subset of users before rolling it out to the entire infrastructure and making it available for everybody. The implementation takes advantage of the networking topology that's in place. For example, a routing rule could be created to say send 10 out of every 100 requests to the new build. So those 10 requests are sent to the new version, whereas the rest of the 90% get the old build. Once this setup is established, the work comes down to simply comparing the metrics between this old version and the new version, uh, mainly system performance and quality of experience. Um, Routing. There's multiple ways the routing could be implemented. It could either be random sampling, like we just discussed, like one request of every 100 or so are sent to the new build, or the sampling could be stratified. For example, like by device or browser. For example, let's route all the Chrome traffic to the new build before everybody else gets it. That's so two strategies that are more popular in routing. So depending upon what's the right way to sample the product, we would be choosing the right strategy for that. Rollout at the same time could also be different strategies. Again, depending upon the confidence on the Canary run or depending upon the situation that makes more sense for the product, one of these rollout strategies could be implemented. Whereas, a gradual increase to 100%. For example, let's say one of our peer teams here at Netflix, starts with a 5% Canary, 5% fraction going to the new build, increases that to 25, then to 50, and then to 100. That's a gradual rollout and is a very good case of using Canary infrastructure in place and rolling it out much more safely. There's also another strategy where you could sample, let's say 10% of the traffic is sampled with the new build. It gives you enough confidence to just switch and replace the new version. Let's take a look at our release process and the Canary implementation. As you can see in the diagram here, a Canary run is very much baked into the release process. All the builds that go to production have to go through a Canary run. Like with everything else, we do have exceptions to this process. We do exempt this process for any production break fixes or hot fixes with a genuine reason to go to production as quickly as possible. Once a release candidate is generally selected at a predefined time, just so the expectation with everybody involved is set for dev, test, and operations. Once the an approved RC is selected, a Canary run is kicked off. We do leverage automated Canary analysis stage that is available in Spinnaker. This ACA or automated Canary analysis is used to determine if a new build is performing as expected, how deviant or not it is from the baseline. And only a build that passes the Canary run is released to production. At this point, a failed canary, if and when that happens, is a very good opportunity for us to, review why and how can this failure be detected sooner in the process. The big thing to note here is that it adds considerable time, to the overall feature to market timeline. So what we are consciously choosing here is a better user experience and more reliable product at the cost of this added lead time. Let's look at the implementation of the canary. Okay, for every canary, along with the smaller canary cluster, an equal-sized baseline cluster is also created. And a routing rule is established to send the same amount of traffic to these clusters. These two things, the same size cluster and the same percentage of traffic, is done to ensure we have an apples to apples comparison between both the builds. In other words, we are trying to keep everything other than the build to be the exact same between these two clusters. Here are the key factors to ensure a successful Canary implementation. Percentage of traffic. In other words, how widely would you want to expose this new build? We do not want it to be too small to give not so meaningful analysis. At the same time, you do not want it to be too high, defeating the purpose of having a canary. 5 to 10% is quite common, depending on the time of the run and the traffic patterns, if any. My team defaults it to 5%, but the release captain has the ability to go up to 15% if they see a need for that particular release to go that wide. Duration of the canary. You want to ensure you have this run long enough to cover most of the core functionality of the product. For an example, my team runs this for 4 hours, mainly to make sure that we do not miss any post episode or post title metrics and any impact, if any, because of this new change to them. Canary and baseline clusters, we just briefly touched on that, is something to keep in mind, especially in cases where we do not have the same or comparable cluster sizes. As I just mentioned before, this is done to ensure we have an apples to apples comparison between the builds. Metrics analyzed. If nothing else, this is the one thing I want us to get hung on. Metrics analyzed. The metrics or parameters chosen to be analyzed between the builds are crucial in ensuring the quality of the canary run. A canary could only be as strong as the metrics analyzed. A simple rule that my team follows is that if it matters to production, it should be in a canary analysis and vice versa. The next important factor I'd say in considering is automating the analysis to remove the manual judgments of deviations versus metrics. Instead, let the math tell you how it's actually, if it's really deviated. At this point, it really truly becomes a math problem. Simple comparison with metrics is really a math problem, and rightly so. What we do is we leverage, as I just mentioned, automated Canary analysis stage in Spinnaker. Marginal and pass thresholds. How you instruct an automated analysis to move forward to the next step or stop where it is and end the canary run. The Spinnaker's automated canary analysis that we leverage in our team in an event of a bad canary stops the canary and kicks off the next stage to deactivate a routing rule, automating the impact detection and also minimizing the impact duration. Let's look at a sample canary config. Here's a canary config, which basically is just defining all the metrics that we are picking and choosing to analyze for a canary run, which means these are the metrics that are used to compare between a canary and a baseline cluster. And how do we define if it's good or bad? Do we fail it if the metric increases or decreases? That configuration is also part of a canary configuration, along with the weightage per metric group. In other words, we're saying that certain metrics are primary metrics that should be prioritized over some secondary metrics that are possibly could be flaky. Okay, this is a sample Canary report that comes out. That's the overall Canary score across all the metrics involved in this report. The threshold defines if the Canary is a pass or a fail. A deviation is done per metric, and the result per metric is basically how the overall Canary score is calculated. The the data on the right-hand side of this page show us how many data points we had, what was the average, the max and mins, and the graph is expandable for us to go and dive in deeper to see if there's any anomalies existing in there. Automated canary analysis is instrumental in helping us quickly identify if a canary run is a success or a failure. So if any team is looking at adopting Canary as a strategy for their testing and production, it's totally worthwhile to invest in an automated analysis tool. It's going to be huge in quickly in making that Canary a success. Let's click a quick look at the varied implementations of canaries. Here are a few that we've done in our team or heard and seen other teams do. On-demand canaries, pretty much like the regular release canaries. On-demand is basically kicking off of maybe a branch in your source code instead of the trunk, the main trunk. This is quite helpful when you have these big features going in and you still, you want to sample test it prior to the merging into the trunk. Regional canaries serve the purpose of minimizing the blast radius. So instead of having a canary of sampling 5% users across all the regions, a canary basically employs in one region. So the blast radius could be minimized to a certain region. Um, so it's great in basically trying to reduce the impact of if there's any user impact. AA canaries. AA canaries, in other words, is basically where our application code is basically the same between both the canary and the baseline cluster. This was very helpful, for example, in your platform migrations. For example, we migrated from infrastructure as a service to platform as a service. In that scenario, this AA canary with the same exact application code on two different platforms was huge help in helping us understand how our future in PaaS would look like. And dark canaries are exactly the same canary implementation, except the dark canary only absorbs the incoming requests, so it's another, but does not respond back to the users. So it's essentially a way for us to see how our system is reacting without actually reacting to the real user. Key takeaways. So, to summarize all of testing in production, what is our most important thing if we want to implement testing in production? Safety is number one. We are playing in production, which is the one environment that matters for the service and for the product. So safety is number one in making sure that we are not impacting the users or the reliability of the service. Testing in production can only succeed if we have strong monitoring capabilities to detect faster and act faster. So invest into the monitoring capabilities. And so is recoverability of a system. By recoverability, I mean if and when things go south, like a bad canary run, how quickly can we detect and how quickly can we revert back to the last good known state? It's basically, in the end of the day, eventually lines up to the safety piece of it, but a story that's worth investing into. And last but not least, get creative when possible and safe to do so. And remember, works in production is so much better than works on my computer. Thank you.